Hi, this is the Liceo Math Club. Hope you're using this time to be productive in this quarantine period. This is Lazaro, the Liceo Math Club's president, and I will be discussing logarithms, specifically solving for the value of x in logarithmic equations with the same base. So as an introduction, this video focuses on the basic lessons of logarithms that are necessary in understanding complex logarithmic concepts in calculus, algebra, and arithmetic, which will be encountered in higher education. For learners to further grasp the discussion, the video will also provide practice questions and essential methods in coming up with solutions for logarithmic problems. The following areas will be covered in this video: definition of logarithms, evaluating logarithms, logarithm laws, simplifying logarithmic expressions, and solving logarithmic equations. Let's start with the definition of logarithms. If b is greater than 0 and b is not equal to 1, the logarithm function with base b is defined by y is equal to log base b of x if and only if b raised to y is equal to x. The domain is from 0 to positive infinity and the range is from negative infinity to positive infinity. Technically speaking, logarithms are the opposite or the inverses of exponentials. In an exponential equation of x is equal to b raised to y, its logarithmic form would be y is equal to log base b of x, with b being the base, x being the argument, and y being the answer or power. If we are asked to write 5 raised to 3 is equal to 125 in logarithmic form, then we simply have to substitute these variables into the logarithmic form equation, such that y is 3, b is 5, and x is 125. Plugging these variables into the formula, then we have 3 is equal to log base b of 125. The same process will be observed in converting log base 3 of 81 is equal to 4 in exponential form. The answer would be 3 raised to 4 is equal to 81. Now find the values of the following logarithms. You may pause the video as you solve for your answer. So, for log base 7 of 49, the answer is 2, since 7 squared is equal to 49. For log base 2 of 8, the answer is 3, since 2 cubed is equal to 8. And finally, for log of 10,000, the answer is 4. For logarithms with no subscripted base such as this, it is assumed that the base is 10. So 10 raised to 4 is equal to 10,000. Now let's test your knowledge by evaluating the following logarithms. Pause the video and solve for your answers. For the first one, log base 3 of 9 is equal to 2, since 3 squared is equal to 9. Log base 5 of 625 is equal to 4, since 5 raised to 4 is equal to 625. Log base 6 of 1 over 6 is equal to negative 1, since 6 raised to negative 1 is equal to 1 over 6. Finally, log base 4 of 2 is equal to 1/2, since 4 raised to 1/2 is equal to 2. When evaluating logarithms, all you need to do is ask yourself this question: at what power of y must I raise b to get the value of x? To help you simplify complex logarithmic equations, logarithm laws or properties are essential in solving these equations. Note that these laws only apply to logarithms with the same base or can only be used in logarithmic equations with the same base. So, the first one is the logarithm of a product or product property. It is denoted by the formula log base b of m plus log base b of n is equal to log base of the product of m and n or mn. Consider the following logarithmic equations. If we add a and b, we will have log base 5 of 5 plus log base 5 of 125 is equal to 4. From this, we could say that the left-hand side of this equation is also equal to the log base 5 of 625. We can notice that the argument on the right-hand side is the product of the arguments of the left-hand side, which are 5 and 125, and when multiplied results to 625. This demonstrates the product property. Checking if the equations are correct, log base 5 of 5 is 1, log base 5 of 125 is 3, and when added is equal to 4, or the value of log base 5 of 625. Let's take another example. Observe that the argument on the right-hand side, or 243, is exactly the product of the arguments of the left-hand side, where 9 times 27 is equal to 343. Let's check the equation. Log base 3 of 9 is equal to 2, log base 3 of 27 is equal to 3, and when added is equal to 5, or the value of log base 3 of 243. Let's proceed to the logarithm of a quotient or quotient property. It is denoted by the formula log base b of m divided by n is equal to log base b of m minus log base b of n. Consider the following logarithmic equations. If we subtract a from b, we get the equation log base 5 of 125 minus log base 5 of 5 is equal to 2. Notice the 2 is the value of log base 5 of 25. Also, notice here that the argument of the right-hand side is equal to the quotient of the arguments of the left-hand side, wherein 125 divided by 5 is equal to 25. This shows the quotient property. Checking the equation, log base 5 of 125 is equal to 3, log base 5 of 5 is equal to 1, and when subtracted results to 2, or the value of log base 5 of 25. Let's take another example. Observe that the argument on the right-hand side is exactly equal to the quotient of the arguments of the left-hand side, wherein 343 divided by 9 is equal to 27. Checking the equation, log base 3 of 3 is 5, log base 3 of 9 is 2, and when subtracted is equal to 3, or the value of log base 3 of 27. Finally, we have the logarithm of power or the power property. It is denoted by the equation log base b of m raised to n is equal to n times log base b of m. Consider the logarithm log base a of p. Log base a of p plus log base a of p is equal to log base a of p squared, according to the product property. Combining like terms in the left-hand side, we get 2 log base of p, and it is equal to log base a of p squared. This demonstrates the power property. So, let's add log base a of p to both the left and hand sides. Combining like terms in the left-hand side, we get 3 log base of p, which is equal to log base of p cubed, an illustration of the power property. Let's use the power property in evaluating logarithms. Here we have log base 2 of 18 minus 2 log base 2 of 3. We can transform this into log base 2 of 18 minus log base 2 of 3 squared, or 9. Then, using the quotient property, we will have log base 2 of 18 over 9, or log base 2 of 2, which is then equal to 1. Refer to this table when applying exponent and logarithm properties in solving equations. Now we'll answer 2 review questions that will test your knowledge on the logarithmic properties. Number 1. Rewrite log base 4 of 64 raised to x. By the power property, this expression will become x times log base 4 of 64. That is then equal to x times log base 4 of 4 cubed. Log base 4 of 4 cubed is equal to 3, so the expression is now equal to 3x. Therefore, log base 4 of 64 raised to x is equal to 3x. Number 2. Simplify log base 6 of quantity AB raised to 4. Through the power property, this will become 4 log base 6 of quantity AB. Using the product property, we can separate log base 6 of quantity AB into quantity log base 6 of A plus log base 6 of B, which are all multiplied by 4. Distributing 4, we will have 4 log base 6 of A plus 4 log base 6 of B. Therefore, log base 6 of quantity AB squared is equal to 4 log base 6A plus 4 log base 6B. Now let's try solving logarithmic equations where we are asked to find the value of a missing variable. The first case will be solving for the value of the argument x in the logarithmic function y is equal to log base b of x. Here we have the equation log of x plus log of 3 is equal to 2 log of 4 minus log of 2. Since there is no subscripted base, it is assumed that the base is 10. So it will become log base 10 of x plus log base 10 of 3 is equal to 2 log base 10 of 4 minus log base 10 of 2. Using the product property in the left-hand side and power property in the right-hand side, we will have the equation log base 10 of 3x is equal to log base 10 of 16 minus log base 10 of 2. Using the quotient property in the right-hand side, we will then have the equation log base 10 of 3x is equal to log base 10 of 8. Since both sides have the same base, we can equate the arguments 3x and 8. We will then have 8 over 3 as the value of x. Here we have a simple equation where the base is the variable. Log base x of 3 is equal to negative 2. Transforming this into an exponential form will lead to x raised to negative 2 is equal to 3. Multiplying the exponents of the left-hand side and the right-hand side with negative 1/2 will result to x raised to negative 2 times negative 1/2 is equal to 3 raised to negative 1/2. Simplifying, we will have x is equal to 3 raised to negative 1/2. It is then equal to x is equal to 1 over square root of 3. By rationalizing, we will then have the final answer of x is equal to square root of 3 over 3. For the last question, solve for the value of v in the equation log base 12 of quantity v squared plus 35 is equal to log base 12 of quantity negative 12v minus 1. Transposing the right-hand side into the left-hand side, we have log base 12 of quantity v squared plus 35 minus log base 12 of quantity negative 12v minus 1 is equal to 0. Using the quotient property, we will have log base 12 of quantity v squared plus 35 over negative 12v minus 1 is equal to 0. Turning this logarithmic equation into exponential form, we will have 12 raised to 0 is equal to quantity v squared plus 35 over negative 12v minus 1. Evaluating, it will result to v squared plus 35 over negative 12v minus 1 is equal to 1. Cross-multiplying the equation will result to v squared plus 35 is equal to negative 12v minus 1. Transposing the right-hand side into the left-hand side, we will have the quadratic equation v squared plus 12v plus 36 is equal to 0. By factoring, the equation will now be quantity v plus 6 squared is equal to 0, where we can derive the value of v to be negative 6. So that ends our topic in logarithms. Don't forget to like and follow our Facebook page under the URL www.facebook.com/Liceo Math Club, and like this video and subscribe to our YouTube channel Liceo Math Club. This has been Lazaro, Liceo Math Club's president, and thank you for watching this video of ours. And remember to be productive in your spare time.